Okay, so we talked about, and you've done some practice on your potential dividers. So where you've got two separate resistors, and you can measure the voltage out across one of them. Okay, so today we're going to look at a similar kind of thing called a potentiometer, which is basically one big resistor that you can split into two using a contact, which we call a sliding contact. And it's usually either a big long wire or a big long resistor that you can split into two, and then you can treat those two resistors separately. But it does have the added advantage that it's variable, so you can change it. You might have it very small at one point, and then you can slide the contact and make it bigger. So variable resistors can be used to change the size of a voltage. When used for this purpose, the variable resistor is called a potentiometer. And when a variable resistor is used to control current, it's called a rheostat. So the output voltage is controlled using a central sliding contact. Now you might have used variable resistors before, kind of things like this. So investigating the potentiometer 1. So this experiment, and I will link you to the video later, is basically you have one big long wire. Okay, so this resistance wire here is just a long wire, and it's connected to a battery, a 1.5 volt cell. Okay, and that is all this experiment is. You'll see here at the bottom, we've got a voltmeter that's connected across one part of the wire with a sliding contact attached there. So what we can do is we can slide that contact to various points at this of the wire. So you might slide it to, say, this part here of the wire, and then it would be a small part of the wire that you'd be measuring the voltage out across. Or you could slide it to this part here, and you'd have a very large part of the wire that you're measuring the voltage across. So this experiment, what we do is we measure the voltage across when the sliding contact starting off at 0 and moving all the way up. So what I'll do is I'll link you to the video where you can see the results. But what you would get is, as you increase the distance of that sliding contact from 0 centimeters all the way to 100, you find that as you increase the amount of wire that you're measuring the voltage out across, the voltage increases because the resistance of the wire also increases, because we know the longer the wire, the bigger the resistance, because you did that in sort of second year and third year electricity. So if you plotted a graph of this, so the distance from 0 versus the voltage, you would get a straight line through the origin. And that shows us that the longer the wire, the bigger the voltage across it, because the resistance is bigger. So we can use that to our advantage. We can change the length of wire that we're measuring the voltage out across. So instead of having two separate resistors, what we have is one big resistor, but we can split it into two. And we can send the voltage across one part to a different part of different circuit, or to control something else. So I'm going to pause that video there and let you watch the